Okay, so since we are done with solving quadratic equation, we are now ready to describe the roots of quadratic equation and to characterize it. Actually, we have characterizing the roots since we are solving quadratic equation. Kumbaga, napahapyawan ko na kayo from some of them. So, to fully understand what I am trying to say, let's proceed with the lesson. So, it's at the end of this tutorial, you'll be able to answer this table later. I know for a fact that you can answer for this part here, since we have discussed it from the first few videos that I have shared with you. The new thing here for you here is this fourth column and last column, which we will discuss now. Okay, so let's have x squared plus 5x plus 6 equals 0. Let's solve for the roots or for the value of x. I will not elaborate on this one. With that, I will be using the quadratic formula, and the value of a is 1, b is 5, c is 6. Rewrite the formula, substitute everything, and then you'll have here 5 squared is 25. 4 times 1 times 6 is 24. 25 minus 24 is 1. Then square root of 1 is 1. And separate them. You'll have negative 5 plus 1 over 2 and negative 5 minus 1 all over 2. Negative 5 plus 1 is negative 4 divided by 2 is negative 2. And negative 5 and negative 1 divided by 2 is negative 6 divided by 2 is equal to 3. So, the first roots, again, pwedeng magkapalit itong dalawang to, ha? Okay, so we have the first root is negative 2 and the second root is negative 3. If we're going to describe or characterize negative 2 and negative 3, how many roots do we have? We have 2 roots. They are real. They are real numbers. Basta positive or negative integers yan, they are considered real numbers. And obviously, they are unequal. So, would it be possible for us to identify or characterize the roots without even solving or without knowing the roots exactly? For let's say we only have this and we do not have the values. Is it possible for us to characterize them just by knowing this? So with that, let's proceed. So b squared minus 4ac. I know you are familiar with this formula because it can be seen in the quadratic formula. B squared minus 4ac is called the discriminant. Remember that. B squared minus 4ac is the discriminant. And the discriminant determines the nature of the roots. When we say the nature of the roots, it is the character, or it gives character to the roots. Is that clear? Okay, let's proceed. It says here, if b squared minus 4ac is equals to 0, then the roots are real and equal. Again, if b squared minus 4ac is equals to 0, the nature of the roots are real and equal. If the discriminant is greater than 0, the nature of the roots are real and unequal. If the discriminant is less than 0, ibig sabihin pag ang value ng discriminant is a negative integer, then the nature of the roots is not real. Okay, let's have our first example. Find the nature of the roots of the equation of x squared plus 4x plus 3 equals 0. If you will solve for the roots of this equation, the roots are negative 3 and negative 1. Suppose we do not know this. So, we have here b squared minus 4ac. Let's use the discriminant. And the value, okay? And the value of a is 1, b is 4, c is 3. Substitute. Substitute the value of a, b, and c to the discriminant and you'll have this. b is 4 squared minus 4a, which is 1, and c, which is 3. Perform the operation using PEMDAS. 4 squared is 16. 4 times 1 times 3 is 12. So 16 minus 12 is 4. Now the value of the discriminant is 4. Now, based from the three situation that we have a while ago, we can say that the discriminant is greater than 0, right? And when the discriminant is greater than 0, the nature of the roots are, it has two real and unequal roots. Again, since the value of the discriminant is 4, which is greater than 0, then the nature of the roots are real and unequal. Is that clear? Proceed tayo. Another example. Find the nature of the roots of the equation of x squared minus 6x plus 9 equals 0. If you are going to solve for the roots is just 3. If you will describe this is real and iisa lang siya, ibig sabihin it is equal. Let's see. Let's use again the discriminant. The value of a, b, and c are 1, negative 6, and 9 respectively. Substitute. b is negative 6 squared minus 4 times 1 times the value of c, which is 9. 36 minus 36 is equal to 0. So, the value of the discriminant is 0. We can say that 0 is equal to 0. When the discriminant is equal to 0, then the nature of the roots are or is real and equal. Again, if the value of the discriminant is 0, then the roots are real and equal. Last example. Find the nature of the roots of the equation of x squared minus x plus 3. The roots of this, if you will solve this using quadratic formula, you will not be able to obtain or get a root. Kasi, ito po yan. Because of the discriminant. The value of a, b, and c is 1, negative 1, and 3 respectively. Substitute it to the discriminant, which is negative 1 squared minus 4 times 1 times 3. Negative 1 is squared is 1. 4 times 3 times 1 is 12. 1 minus 12 is negative 11. Negative 11 is less than 0. Basta negative, mababa yan sa 0. So, with that, since b squared minus 4ac is less than 0, then the equation has no real root. Kahit hindi natin na-solve yung value ng x, malalaman natin yung characterization or nature ng roots by just simply using or getting the value of the discriminant. I hope this one is clear to you. Okay, so with that, let's complete the table now. Okay, so first one we have, yes, 1, 2, 1. Using the b squared minus 4ac, what is the value of the discriminant? 0. So what is the nature of the roots? Since it is equal to 0, real and equal roots. Let's proceed with the second equation. value of a, b, and c, 1, negative 5, negative 6. The value of the discriminant, 49. 49 is greater than 0. The nature of its root are real and unequal roots. And lastly, we have 2, negative 1, 3. The value of the discriminant is negative 23. And negative 23 is less than 0. Therefore, the nature of the roots of this equation is no real root, or they are not real. So with this lesson simply tells us that even without solving for the value of x, or for the value of the, or for without even getting the roots, we can identify or we can describe them by simply using the formula for the discriminant. Okay, that's all for today. We'll see you next time. Thank you.